welcome back. So last class we finished insertion sort, wherein we did the trace, the algorithm as well as the program. So we finished with the algorithm, wherein the algorithm is written with a while loop, whereas the program I had written with two for loops. But you can interchange both, like whichever loop you want to, you can write. Like you can write one for and one while, or you can write both the fors. Only thing that matters here is the logic should be proper. To know that, you need to trace the program. So if you trace it, at least this function, if you trace, you will know what you've written is correct or not. The next is merging. As the name suggests, it combines data items like two files into one. So that is merging. Merging of two or more files into one to form one, like two or more arrays to form one is a merged array. Like you have two separate arrays A and B. You can see A as a linear array wherein in the location 1, position 1, 10 is stored, 20, 50, 80, 95 and 100. So they have stored 1 to n elements here, and the other array is B, which has 4 elements. The first array has 6. So after merging, the resultant array C will have 10 elements. Like it depends on you how you merge. You can start with B and then merge A to B, like 20, 35, 45, 90 and then the elements of A, or you can start with A and then merge B. Merging is nothing but joining of two or more arrays. As a user, you can decide which, I can say as a user also, or as a programmer, you can say that which array should be written first and then which should be followed. Like the sequence is set by you, or as a programmer, you can program in such a way that you can set the sequence of the array. Fine. So this, you don't have a program for this or algorithm. You should know like what is merging of an array, but for your better understanding, I will show you the execution of the program. Before that, please have a look for this about what is merging. Now we'll see the execution of the merging program. So merging is a concept which is there for you, like it is one of the operations performed on arrays, but then you're not supposed to write a program for it. It's a concept wherein you can merge more than one array into a single array. Okay. So let me go take you through the program so that you will know the logic. It's very simple only. Like you have two arrays here. One is array A and the other one is B, wherein I will also have an array C in which I am going to merge both A and B. So A is an array with maximum of 10 elements and B also with maximum of 10, wherein C has 20 because when I write the merged array, so it should have the size, double the size of these two. That is the combined size of these two, not the double. Like I can say, then I combine the size of A and B. C should have that size N, M, I and J. So there are three integer arrays A, B and C, and then variables N, M, I and J. Then I have in the public section three functions: input, merge and display. And all the functions do not return any value, nor I am going to pass any arguments to it. So this is like void input semicolon, void merge semicolon and void display semicolon is nothing but function declarations. So I have declared the function inside the class merge array and I am going to define it outside. This one they can ask you declaring inside and defining it outside. So the three member functions are declared inside and I'm going to define that outside the class. So how do I write it outside? The return type of the function, that is for input function, I can see that the return type is void, name of the class to which it belongs to, merge array and input. So what am I asking? Enter the number of elements in the first array. Yes, since I am reading two arrays, because I need to merge two, right? So I am reading two arrays. I will ask the user to enter the number of elements in the first array. And I am going to read that number of elements in n. So n is a variable of type integer which is going to hold the number of elements in the first array. After that, I'm going to ask the user to enter the array elements. That is, I'm going to read the array elements. I'm going to read elements of array A. So I'm going to take I is from 0 to n minus 1 because the array subscript starts from 0. So I'm going to read the array from 0 to n minus 1 and I'm going to write it in I'm going to read it to array A. So array A will contain the first array entered by the user. Next, I am going to ask the user to enter the number of elements in the second array. That is how many elements I am going to have in the second array, and that number I am going to store in the integer variable m. So m is an integer variable which is going to hold the number of elements in the array 2, whereas n is an integer variable which is going to hold the number of elements in the array 1. After that, I am going to ask the user to enter the array elements. I am going to read it to array B. That is, I am going to read array B, which is the second array with m elements, and array A is the first array with n elements. Hopefully you're clear with the input function. That is, you're going to read the array A, array B. The total number of elements in A is n. Total number of elements in array B is m. After that, I'm going to do the merge. So what is the merge thing? I'm going to merge. First, I'm going to write array A and then I'm going to continue with array B in the array C. So first, I need to read the array A and write it to array C. So C will start from 0 only. And how many elements are there in array A? N. So 0 to n minus 1 would be all the elements of the array. So C of I, that is C of 0, is equal to A of 0. Like that, I will read all the elements from array A to array C. Like I will write it, right? I am writing the elements from A to C. So C of I is equal to A of I, that is A of 0 is C of 0, then A of 1 is C of 1, like that up to n minus 1, 0 to n minus 1 I am going to write. After that, I need to continue writing. I cannot rewrite again. I need to continue writing from the nth position because n minus 1 till n minus 1 I would have written array A. Suppose array A has 5 elements. What I'll do, 0 to 4 would be the array A because those are 5 elements. And from the 5th position, I need to start writing array B, right? So for that reason, I is equal to n and j is 0 because I need to read the array B from the first element, right? So array C will start from n, but array B I need to start from 0 to m minus 1 because m is the number of elements in B. So C of I, that is, this I will have the n value because till n minus 1 I would have had array A. So I need to start from the n location to write, otherwise it will rewrite it. So C of I is equal to B of J. B of J is B of 0 because I need to start from the first element of the second array. Like that, I'm going to write. And in a for loop, if you want to have multiple variables, see, I have two variables here. They need to be separated by a comma, and each section of it, that is the initialization, condition, increment or decrement, each part of the for loop header should have a semicolon separator. Getting it? So then I'm going to display the first array. then the second array, as well as the merged array. In the display function, I am just going to do that. Hopefully, you have understood all the three, and then you create an object, because only through object I can access the member functions of the class. Whichever is written, data members or member functions of the class, which is declared in the public section of the class. Only when you declare an object for a class or create an object for a class, memory would be allocated for the class. So MA is the object for the class merge array. Then I need to call in the proper order. So first I'll call the input function, the merge, and then the display function. So we'll run this now. Run the number of elements in the first array. For example, if I say 5 elements, enter the elements 1, 2, 3, 4 and 5. After that, enter the number of elements in the second array. The number of elements, if I say again 5 elements, I have 6, 7, 8, 9, 10. These are the elements in the second array. Then the first array, I have written 1, 2, 3, 4, 5. Yes, I had entered the second array 8. Oh, I entered like that. Then it is, yeah, I have entered 8, 7, 8, 9, 10. 6 instead of 6, I entered 8. That is okay. Whatever I want to, I can enter 8, 7, 8, 9, 10. You can see the merged array in the proper order only. So let me take you to the display function. I wanted to show you one more thing. When you are writing the displaying the combined array, the size of the array would be m plus 1, m plus n, because the number of elements in the first array plus the number of elements in the second array would be the size of the merged array. So 0 to the total size minus 1 would be the size, like 5 plus 5 is 10. So 0 to 9 would be the size of this array. So hopefully you've understood this. Like, let us close and exit. Okay. Quit of the merging. So merging is a concept wherein you can combine more than one array into, or more than one list into a single one, is merging. So that is one of the operations in an array. So we completed with traversal, insertion, deletion, searching, sorting and merging. We have done all the array operations. We have done programs for the first 5, that is traversal, insertion, deletion, searching and sorting. And merging is just for your answer, wherein they ask you the different operations performed or what is merging. But they will not ask you a program, but anyway I have shown you the execution exactly how it looks for your understanding. Now we'll continue with two-dimensional arrays. Till now whatever we did was one-dimensional array. Anyway, binary search you cannot apply binary search on a two-dimensional array. Linear search you can do, but you cannot do binary search on a two-dimensional array. Now two-dimensional arrays. What is two-dimensional array? A two-dimensional array is a collection of homogeneous set of elements only, wherein each element is identified by the pair of subscripts. The first one would be a row number and the first one is the row number and the second one is the column number, that is R and C, wherein for in this example you can see 10 is identified as the 0th row. Position of that element is 0th row and 0th column. 20 is 0th row and first column. 30 0th row and second column. So each element will have two subscripts. One is the row position. The first one would be the row position and the second one would be the column position, and again they are also stored sequentially in continuous memory locations. But only thing is they will have the position of the row number as well as the column number. Like for example, 70 can be identified as the second row and the 0th column. Yeah, it will have two subscripts. The first one would be the row number, which is the row position is 2 and the column position is 0. So 70 would be A of 2, 0. The element present in that location, the element present in that location would be 70, A of 20. That is the row position and then the column position. The number of elements, how can you obtain? By multiplying the total number of rows into total number of columns. Like if I say 3 cross 3, then I will have 9 elements, that is 3 rows and 3 columns, which is 9 elements, 3 into 3. So you can obtain the number of elements by multiplying the rows, number of rows into number of columns, and then these can be represented in the form of matrices. Last year we have done one entire chapter on that. So you have understood or you remember that. If not, please go back and refresh it. Have a look. The next, yes, they will ask you this in the exam, the row major and the column major representation, wherein in a two-dimensional array of m cross n, order of m cross n, to store m cross m into n number of elements, we need m into n memory locations. Yes, 9 elements if you want to store. For example, you can take like 3 rows and 3 columns. So I need to store 9 elements and then I need that many memory locations. For example, if I am storing an integer, then that many blocks of memory I would need to store 9 integers. So that many, yeah, you need, and then there are also continuous memory locations, and then you can store it in two different, the storage can be in two different methods. One is row major method and the other one is column major method. That is, an array of order m cross n can be stored in continuous memory locations in two methods, row major and column major. So an array, two-dimensional array, can be represented in row major method and a column major method. We'll see what is row major and what is column major. So all the first element rows in row major method, all the first element rows are stored in sequential memory location, and all the second, that is, it stores row wise. The first row one will come first and then the second row and then the third row. That way it will go on storing the first row first, that is the 0th row, because the subscript starts from 0. If there are total 3 rows, it will start from 0th row, all the elements will be stored, then the first row elements and then the second row elements. This is how it will store in row major. Like for example, you take 10, 20, 30, 40, 50, 60, 70, 80, 90. So 10 is in 0th row, 0th column. So it is stored first, and then you have 20 which is 0th row and first column. Then you have 30 which is in 0th row and second column. So you see here, first row is completed. Then you start with the first row. That is first row, 0th column, first row, first column, first row, second column. Like row by row you are going to store in row major method. That is, the 0th row all the elements, then the first row all the elements, then the second row all the elements. It goes on that way. So next, in column major method, what happens is you store it column wise. That is, the same elements you can see here. 10 is 0th row, 0th column, so it will be first. Then you will store first row, 0th column, first column, 0th row. Okay, the first column, zeroth row. 40 would be stored next. Whereas 40 is stored here in row major, here in column major, 40 would be stored because I am storing it 0th column first column first, and then the second column. So it will store 40 would be stored because 40 is in first column 0th row. Then you have second column 0th row. Fine. And then you have 0th column first row, then first column first row. So you can see the sequence of same array elements in different ways here. Here it will first store the first column elements, then the next column elements, and then the next column elements. Whereas here it would be the first row, second row, third row. Like row wise you will store here in row major, column wise you will store in column major method. That is, first you will start with a 0th column because subscript starts from that. First you will store all the elements of the 0th column. So the row will change, but still the column remains the same. And then you take the first column wherein you will store the row again will change, right? But you will store the first column and then you will store the second column and so on. It is first column, second column, third column. The column wise in row major it will be row wise. That is how the elements are stored. Now this is very important. It's a 2-marker or a 3-marker question. The computer does not keep track of the addresses of A and J of every element in an array. Suppose I have a 3 cross 3 matrix. It is not like A of 2, 3. That is A of second row, third element, or sorry, it's 3 cross 3. You won't get 2, 3. You will get 2, 1. For example, if I want to take in the I want the address of the element present in the second row first column, how will it retrieve? It will not keep the address of it. The computer does not keep track of the addresses of all of that. What it does is it will just take the base address. Base address is nothing but the address of the first element of the array because it is continuous memory locations. So if you get the first address, you can easily get the remaining addresses also. Like if it is integer, then 2 blocks would be for integer. If it's float, then you will have a jump of 4 blocks, right? Each element is stored in the 4 blocks of memory. If it's a character, it will be 1 block. The base address is nothing but the address of the first element. That is, if it is a 2-dimensional array, the address of A of 0, 0 would be the base address. And array name is a constant pointer which points to the base address. That is the address of the first element of the array, and then since they are continuous memory locations, that is they are physically stored one next to another, you can easily retrieve the addresses of remaining. So it does not keep track of the addresses of all the elements. It keeps the track of only the address of the first element, that is the base address. Base address is nothing but the address of the first element of the array. Then the computer uses the following formulae to retrieve a particular element from the memory. So they will give you problems. We will be solving 4 problems here. 2 for row major and 2 for column major. Like if the array is stored in row major method, what is the formula we need to apply? That is the location LOC of an element A of ij, where I would be the row number and j would be the column number, is equal to base of A, that is the base address of the array, plus W is the word length, that is how many bytes is allocated for one value, into M. What is M? It is the number of columns, total number of columns, into I plus j. Getting it? So this is the formula you need to learn if the elements of an array is stored in row major representation. If the elements are stored in column major representation, LOC of A of ij is equal to base A plus word length W into n. What is n? It is the number of rows into j plus I. So this formula you need to remember. Please have a look. Then we'll continue with the program. Start with the problems. So what is the first one? Consider a 3 cross 5 matrix array A. Okay. If computer stores array A in row major order, obtain the address of A of 2, 3. So if it is 3 cross 5, it is 3 rows and 5 columns. So the total number of elements I can store is 15 because 3 into 5 is 15. So please make a note of this question. Consider a 3 cross 5. I have 3 rows and 5 columns. 3 row 5 column matrix A. If computer stores array A in row major representation, obtain the address of A of 2, 3. See here they have not given the word length also, as well as they have not given the base address. So I should say which block of memory will it be present. Since it is continuous, whether it will be there in the first block, second block, third block, because each block is one next to another. Block is nothing but the word length, like how many bytes would be required to store one element. If it's a character, the block would be of 1 byte. If it is a float, then it will be 4 bytes. Like that, each block of memory would be for storing one element depending on the data type. So here I need to say which block of memory would be the element in the position A of 2, 3. That is, A of 2, 3 is nothing but the element present in the position second row and third column. 0, 1, 2. That row and third column present, because I do have third column because it's a 3 cross 5 matrix wherein the row would be from 0, 1 and 2, column would be 0, 1, 2, 3 and 4 because total number of columns is 5. Please make a note of this, then I will show you how to solve this. So what was the question? It is 3 cross 5, and then how does it store? It stores in row major order. When it is in row major order, LOC for row major order. Let me increase the font of this. Font size. Okay. For row major order, what is the location of the element? That is LOC of A of I j is equal to base of A plus W into M star I M star I plus j. Yes, this is the formula for elements stored in row major representation. Base A plus W into M cross I plus J, where what is M? M is equal to number of columns, then what is N is equal to number of rows, right? N is the total number of rows and M is the total number of columns, and location of ij is equal to base A plus W, where W is the word length, into M cross I plus J. Now, in this given problem, what is N? N is the, what was the order of matrix? The order of matrix was 3 cross 5. So, 3 rows and 5 columns. So, what is the N value here? N value is 3. And then what is the M value here? That is the columns is 5. Okay, I will take word length since it is not given as 1, and let me take base address also as 1 only since it is not given. Okay, when it is not given, you take that only. So, what was the question? What is the location of 2, 3? So, LOC of A of 2, 3 is equal to base A. I will take it as 1 since it is not given. If they give, you need to take that. Word length is not given, so I will be taking as 1 byte. Okay, into what is M here? M is nothing but number of columns. So M is 5 into what is I? I is A of ij, right? I is 2 plus j is 3, which is nothing but, yes, 1 plus 1. 5 into 2 is 10 plus 1 is 11. So it is 1 plus 11, right? 1 into 11. So it is 11, which is nothing but, so yeah, sorry, 5 into 2 is 10 plus 3 is 13. 13 into 1 is 1. So it will be 1 plus 13. Yeah, here 10 plus 3, that is 13, into 1 is 13 plus 1. So which is equal to 14. So the element is present in the address of the element is the 14th block of memory. Because it is continuous memory locations, the address of the element is the 14th block. So if the address of the first block is 10 and then each block is of 2 bytes, so you can get the 14th block. One block is 2 bytes, so 14th block is what? You can find it out since it is continuous memory locations. So the address of the element is the 14th block of memory. In the 14th block, this element would be stored in a continuous location. So this is the solution for the first question. Please make a note. Then we can proceed with the next question. The next question is, consider a 3 cross 5 matrix. Please make a note of this. Consider a 3 cross 5 matrix. If computer stores array A in column major order. So the previous one was in row major. This one is in column major. So if the computer stores the array in column major order, obtain the address of 2, 3. That is, the element was present in the second row, third column, 2, 3. So you need to find the location or the address of that element. Since again here also they haven't given you the base address, so you need to specify which block of memory it would be stored. Please make a note of the question, then we can go back and find the solution for that. The second one, this was the first one, the second, yes, column major, right? So according in column major, what is the location? LOC of A of I J is equal to base A. Base A is nothing but the address of the first element in the array is the base address. Word length, that is how many bytes is required to store one element. It depends on the data type of the element. Then into, so it is n star j plus I. N star j plus I, where n is the number of rows and m is the number of columns, where n is equal to number of rows. Number of W is equal to word length. Okay. So here this is the formula. What was the question? The question was the order of the matrix. Order of the matrix was 3 cross 5, right? 3 cross 5. So what is n value here? N value is, n is the number of rows. So n is equal to 3 because n is the number of rows, and m is equal to 5. That is the number of columns. So, and you need to find the LOC of LOC of A of 2, 3 is equal to, since base address is not given, I'll take it as 1 star, and word length is not given, then I'll take it as 1 into. So what is the formula? N into J. What is N here? 3 into what is J here? J is 3 according to A, 2 and 3, I and J. That is how I store, right? A of IJ. So A of 2, 3 is nothing but what is J here? 3 plus I. What is I? I is 2. So what would be the answer for that? It would be, sorry, here this is 1 plus 1 into 1 plus 1 into this. So what is the, here it will be 1 plus 11. Yeah, which is equal to 12. So the address of the element is the 12th block of memory. Element A of 2 and 3 is so from the same thing, see, the same element I am checking, but in row major it is in the 14th block of memory, whereas in column major the same element is stored in the 12th block of memory. So the address of the same element when you are representing it in row major and column major is not same, because in row major you will be storing the elements row wise, that is the first row, second row, third row, whereas in column major you will be storing the elements column wise, that is it will be the first column first, then the next column, and the next column, and so on. So we found the address of same element, that is A of 2, 3 with the same array dimensions, that is 3 cross 5 matrix array. But in row major it is stored in the 14th block of memory, whereas in column major the same element stored in the 12th block of memory. Please make a note of this. Then we have remaining 2 more problems. We'll solve that. The next question, please make a note. Consider a 2 cross 6. So what is the n value? N is 2, m is 6. That is, n is the number of rows, that is 2, and m is the number of columns, that is 6, and the name of the array is Q. Okay, you have an array Q, matrix array Q, which is 2 cross 6 array. That is, I have 2 rows and 6 columns. So it will be 12 elements together. Suppose the base address, that is the address of Q of 00 is 400. And there are 4 words, that is each element requires 4 bytes of memory. So each block of memory, suppose if it's a float array, then each element would require 4 bytes, right? So there are 4 words per memory cell and the array is stored in row major order. Find the address of Q of 1, 4. Getting it? So the array, please make a note, then we will solve this. Yeah. So in row major, what is the location of the address? So row major LOC of A of I J is equal to base of, here it will be Q, right? Because the array is Q, plus W into, yeah. Now what is the formula? If it is row major, it will be M into I plus J for a row major representation. N, okay, sorry, row, yeah, for a row major representation, this is the formula, that is base Q plus W into M into I plus J. So now according to the problem, what was the location of the element I was finding? I need to find the LOC of Q, right? Because the base address of Q means it has to be Q only. Q of 1, 4. You need to find the Q of 1, 4 is equal to, so let me say, what are the different, what was base Q is equal to 400. That was what they had given. And what was word length? 4, right? They had given the word length also as 4 bytes. And what is n? N is the number of rows. It was a 2 cross 6 matrix. So number of rows is 2 and number of columns is 6. So the m value is 6. This was the thing what they had given, that is base of Q was 400, W was word length was 4 bytes, and then N is this, that is N is nothing but the number of rows. Since it was a 2 cross 6 matrix, the number of rows was 2, and then M is the number of columns. It was 2 cross 6, the column was 6. Now put these in the formula. What is base address? Base address is, base of Q is 400, then plus what was W, 4 into what is M here? M is 6, right? 6 into I. So what is I here? Ij. Q A of Ij, I have written Q of Ij, same thing. 1, I is 1, plus J is 4 here. So I need to add 4. Yeah. Now please calculate it. It would be equal to 400 plus 4 into 6 plus 4, that is 10. Then which is equal to 400 plus 40, which is 440. This is the memory location or the address of Q of 14. So I say of Q of 14 is equal to this. $440. So this is what they expect you to solve if it is in row major. Please make a note of this so that we'll do the last problem. Please make a note. Next, the last problem is consider a 4 cross 3. So the total number of elements is 12. The number of rows is 4, that is n value is 4 here, and m is the number of columns. The total number of columns is m, which is 3. Matrix array Q. So the name of the array is Q, and it is a 4 cross 3 matrix where 4 is the number of rows, which is nothing but the n value, and 3 is the number of columns, which is the m value. Suppose the base address, that is the address of Q of 00 is 2500. That is the base address of this is 2500, and you have 2 words per memory cell. That is, each element is stored in 2 bytes of memory space, and the representation of the array is in column major. That is, the array is stored in column major. Find the address of Q of 21. So please make a note of this question, then we will solve this. Okay. So what is given here? The given is base of Q, right? Is equal to 2500. After that, number of rows is equal to n is equal to, what was the total number of rows there? 4. 4 cross 3, right? Number of columns is equal to m is equal to 3. The total number of columns were 3. And then element size or the word length were 2 bytes. The element size is nothing but the word length was how many bytes? It was 2 bytes. So I will say 2, right? After this, what was the representation? The representation was column major. So you need to find the location of Address of, what was the thing? Q of 2, 1. Right? You need to find the address of Q of 2, 1. What was the formula for column major representation? LOC of A of ij, or I can say here it's Q. So Q of ij is equal to base Q plus W into N into J plus I. Yes, this was the formula, W into N into J plus I. Now LOC of Q of, what was the thing I need to find? 2, 1. 2, 1 is equal to basis 2500 plus W is 2 into N. N is 4 into J. J is 1 here. Plus I is 2. Right? Which is nothing but 2512. That is 4 plus 2 is 6. 6 into 2 is 12. So it is 2512. Address of Q of 2, 1 is equal to 2512. This is the answer for it. Please make a note. Hopefully you've understood how to solve. Only thing is, you need to by heart the formula. You should know the formula, then you will get it very easily. So row major, column major, we did all the 4 problems. So today we finished with merging, and we went through a program also. Then the array representation, that is 2-dimensional array representation, row major and column major. How are they different? And then how do we find the location of a memory address of an element in an array? Then given the ij values as well as the word length and the base address. We did problems on that. Next class we will be doing advantages and disadvantages of arrays, and we'll be starting with stacks, which is another data structure. So please note down the homework questions for today. Give the memory representation, that is row major and column major, of a 2-dimensional array, wherein you need to write a diagram wherein it will show you how exactly the elements are stored row wise as well as column wise. And then the next question is, how do we determine the memory address of a particular location using row major and column major method of a two-dimensional array? Please note down these questions. Stay safe, take care, see you tomorrow. Bye bye.